Hey, this is Ryan Jones with Serverless Guru. In this video, we're going to be covering how to create a DynamoDB table inside of our serverless.yaml file. So to do that, we're going to go look at the serverless framework. We're going to search their docs for DynamoDB. It looks like we may not be able to find it by searching in that fashion. So what I'm going to do is go ahead and search serverless. Actually, this is going to be a CloudFormation DynamoDB. So as I was saying in the previous video towards the end, we can mix in CloudFormation into our serverless.yaml file and use their specific syntax. So if we scroll down towards the bottom, they have examples about how to actually set this up. So we're going to copy the YAML example and copy down to the end of provision throughput. So this is kind of all we need for our use case. So we're going to say resources, and then we're going to add this here. So we have this logical ID, which is my DynamoDB table, and it's a type of AWS DynamoDB table. We have attribute definitions. This is where you basically set up what your primary key, sort key, things like that. So a primary key, it's similar to any other database. They may call it a hash key, which you can see here, but it really stands for something that closely mirrors a primary key. So we're going to set the type of this attribute as a string, and we're also going to change the key schema, which is right here, to say that this ID field, this ID attribute, sorry, is a key type of hash, which is basically saying, hey, ID is our primary key. So anytime that someone wants to query something or insert something, we need this ID. Okay, cool. So, and we lowered the read capacity and write capacity down to 1. This is the lowest level that they can be at, and it's the cheapest for us personally. It's about 60 cents per month to have a one read, one write capacity DynamoDB table like sitting there. So this is good in that fact, kind of what we want. As we move forward, maybe towards the end of this video, we can show how to abstract this information out into our config file to basically increase the abstraction a little bit more and kind of show how you add additional files or additional fields to the config file and pull those in. All right, cool. So we have this set up. So we're ready to make our deployment. So what we're going to do now is we're going to do Sls deploy --stage dev --v. We're not going to set the region, we'll just leave that as US East 1, and we're going to deploy. Okay, so it looks like our stack is moving forward properly. And while this is deploying, we can kind of start thinking about how we would actually take some of these values and abstract it out to the config file. Okay, all right, so it looks like we have an error. So it says cannot read property type of null. Okay, so if we look at property type of null here, this is referring to this. I have somewhat of a long history of running into these errors, so I know pretty quickly exactly what this is talking about. But there's also this thing called Sls Debug. So let's go ahead and run this. So it's a environment variable, so we have to say export Sls Debug equals star. And then now let's try to rerun this and see if we can get a little bit more information. Okay, so this is great. It gives us a printout to kind of see what's happening. Let's see if we can narrow this down. So although it's giving you a little bit more information, it's still somewhat hard to tell where it's coming from. I guess this would be one of the things that I would say is a downside is that it's actually being worked on, actively being worked on. With that, there comes sometimes where you hit an error and you're kind of scratching your head. But what we can see here is And I would say anytime that you have something coming back as null that shouldn't be null, definitely check the formatting, right? So this type needs to be tabbed over. If it's not tabbed over, it will throw errors. And so part of the reason why I did that was to kind of show that this is actually a common problem. I think we saw this earlier with the stage, but maybe we didn't. But if the space is off, then the entire thing gets screwed up. So, and the log doesn't say like, hey, fix your formatting, which would be nice, but they don't have that. So, or not to my knowledge. Maybe that's a area for improvements that one of the people watching can make. So yeah, so we're redeploying, we're creating this DynamoDB table. Let's go ahead and switch to the AWS console, go to services and type in DynamoDB. So right now we're in the US West Oregon. We're going to switch this back to US North Virginia. This is where we're deploying our table. Okay, looks like our table is currently up, and we can see that it is my first app, which is our service name, dev, which is our stage, and then my DynamoDB table, which is our logical ID, and then a random string at the end, random ID. So as you notice, we didn't actually give this table a name. What CloudFormation does automatically is that if you don't pass a name, it will just create one for you. And so that's why we have this name. And it's actually not a bad thing. So if you don't pass a name, that means that CloudFormation handles the naming convention for you, which gives you the benefit of making your stack very dynamic and very generic, right? So that means that whether you pass it to another team, or you hand it off to a coworker, or you just need to keep redeploying it for different customers or use cases, then you don't have to worry about manually going in and changing these specific values. So this config file helps, but you can almost save yourself even more time just by maybe removing some names. And then if you did want to reference that name, there are ways to get the name of the table by using intrinsic functions inside of the serverless file. So intrinsic functions, they allow you to do things like get the attribute of a logical ID. So we could say like basically give me the name of this logical ID, and it'll give you back the table name. And that allows you to kind of get back a name of something even though you don't know what CloudFormation set it as. So that's super cool. I'm going to make a video about intrinsic functions soon. So just stay tuned for that, and we'll be able to see how this is actually done. For now, we've got this table that's deployed. Let's go ahead and create an item just for fun. So we can say 1, 2, 3 ABC and hit save. Cool. So we have our first item saved. We have this deployed inside of our dev stack in US East 1. And now if we wanted to redeploy this, it would only take a simple --stage test, and we could immediately spin up a test database as well with our exact same Lambda function code and everything else. So very powerful. As you can tell, this right here is actually coming from the CloudFormation documentation. So instead of it being kind of this type of syntax where serverless is actually defining how you create this, this is coming directly from CloudFormation documentation. So this should be an exciting thing to realize, because that basically means that anything that CloudFormation supports can also be worked in to serverless. At the end of the day, the serverless.yaml file is being compiled into CloudFormation, but if you don't take that look underneath the hood, then you may not know that this is a possibility, and it comes in handy a lot because not everything is supported by serverless, and that's for good reason. And so because you're allowed to implement CloudFormation, it basically gives you this ability where you can practically do anything. So so this is the end of this video. This is Ryan Jones with Serverless Guru. See you next time. Bye.